Hi guys, so in this video we are going to look at measuring segments. And this is the third day of notes for us. The first notes that we need to look at is the ruler postulate. And so the ruler postulate just says that points of a line can be put into a one-to-one correspondence with the set of real numbers so that no 2 points are paired with the same coordinate. And it's pretty much just like a number line. So we're just saying we can use a number line to look at these numbers and these variables and give coordinates to these. And that no 2 points will be the same coordinate. So looking down here at this nice little number line, remember that the names of the points are the letters, and for this number line they're on top. And the coordinates of the point are the numbers, and those coordinates are on bottom. So the number is the coordinate. And we're just using a single number line, so they only have one coordinate point. If it was in a graph, your point would have 2 coordinates, an x and a y. For these examples, they'll all only have one coordinate, which is just the single number. Some terminology and the way we write things. We're now talking about segments. So when we have AB with just a little line on top with no arrows, so just a little segment, then we refer to that as segment AB. When we're talking about lengths of segments, then we no longer need the line. So we just put AB, and we know that we're referring to the length. So if there's a little line on the top, then it's called segment AB. If there's no line on top, it's the length of segment AB. It's important to note that if we talk about the length of CJ, the distance between points C and J will be a number value, and that number can never be negative. And that's because it's a distance, right? So your distance is never negative. You can't walk a negative space. You only walk a positive space. To find the distance between 2 points, you can subtract the coordinates and then take the absolute value to ensure the answer is positive. So the best way, remember that absolute value makes things positive. So the best way to think about this is to really just always do big coordinate minus little coordinate. So we are going to use the number line from the top to answer these questions. So we're looking for the length of BD. So if we know that B is at the coordinate -3, D is at the coordinate -1, -1 is the bigger number, so we're going to do D minus B, which will be -1 minus -3, which is 2. So the length of BD is 2. If we're looking at AM, A is at -4, M is at 8. Obviously, 8 is the bigger coordinate. So we are going to do M minus A, which will give us 8 minus -4, and thus gives us 12. So our length of AM is 12. Looking at EK, E is at 0, K is at 6. So we're going to do K minus 0, not 0, K minus E, which will be 6 minus 0, which is 6. So the length of EK is 6. Obviously, you could also just look at your picture and say, okay, from 0, I go 1, 2, 3, 4, 5, 6. So my length is 6. And then finally, HM. H is at 3, M is at 8. So we're going to do M minus H, which gives us 8 minus 3, which is 5. So you can always do these mathematically, or you can reason through them visually by counting on your number line, whichever way works for you. All right, so now we have the segment addition postulate. And that pretty much just says that if 2 points, A and C, are on a segment, a third point B lies on the segment only if AB plus BC equals AC. So what they're saying is, in order for a point to be between 2 points, the sum of the pieces of the segment have to add to be the entire segment. And that should make sense because if I look at this segment SI with R in the middle, if I take this piece of the segment and I add it to this, let me do this differently. If I take this piece of the segment and I add it to this piece of the segment, those two pieces should add to this entire segment. So if R is between S and I, then SR plus RI will equal SI. Notice since we are talking, there's no segment symbols we are using because we are talking about lengths. So the length of SR plus the length of RI is equal to the length of SI. So looking at number 1, if we know that SR is 15 and RI is 21, we're thinking about this picture here. So SRI, we have 15 and we have 22. So the entire length of SI will be whatever SR is plus whatever RI is. So SI will equal 15 plus 22. So SI will equal 37. And that's the length of SI is equal to 37. If we know the entire length, then we can use subtraction to help us. So in this next example, we have this picture. So we have S, we have R, and we have I. So SR is 5. They told us that the length of SI is 18, so the entire length is 18. So use your same little equation. SI is equal to SR plus RI. So SI is 18, SR is 5, and we don't know what RI is. That is what we're looking for. So then we minus 5 from both sides and get that 13 is equal to X. So the length of RI is equal to 13. With these, it's very important to actually draw out your picture and visually see what you're talking about so that you can know where everything needs to go in your equation. If we're looking at C, we're going to throw some algebra in there. So we still have this same picture, S, R, and I. They're telling us that SI is 60. So this entire length is 60. Then they said that the length of SR is 2x minus 8, and the length of RI is 3x minus 12. So just like before, SI is equal to SR plus RI. So 60 is equal to 2x minus 8 plus 3x minus 12. And then you'll solve that equation. Remember, you solve by combining your like terms. So 60 is equal to 5x, and negative 8 and negative 12 makes minus 20. I'm going to add 20 to both sides to get 80 equal to 5x. Divide by 5, and we get that x is equal to 16. Always make sure you look back at what the question wanted. So the question wanted us to find x and then find SR and RI. So let's make a little, so we know that x is equal to 16. To find SR, we're going to plug 16 in for x. So SR will be 2 times 16 minus 8. So 2 times 16 is 32, minus 8 is 24. So SR is equal to 24. RI will then be 3 times 16 minus 12. 3 times 16 will be 48, minus 12 gives us 36. So RI is equal to 36. It is extremely important that you remember to look back and see exactly what the directions are asking you to find. A good check would then be to do 24 plus 36 and see if that gives you 60. If it doesn't, then you know you've done something wrong in your algebra and you need to go back and check. If it does, then you're probably right and you can move on. The last piece we need to talk about is congruent segments. And that little symbol got a little chopped up there, but the congruency symbol, remember, is the equal sign with the little squiggle on top. And congruent segments are segments that are equal in length. So they have to have the same length. So this number line is the same one as the one from the beginning. I just pulled it down so you could see it easily. Congruent segments, always the same length. So to prove that two segments are congruent, we want to look at their length. So if we look at BG, notice that when we talk about congruent segments, we have the segments symbol there. When we talk about lengths of segments, then we're talking about we don't need that length, and lengths are equal, so we wouldn't use the segment symbol when we write things equal. So if we were saying BG is congruent to DK, we write it just like it's written there. But if I wanted to say that BG is equal to DK, then I'm talking about the lengths, so I wouldn't need the segment symbol. So the length of BG, if we look, B is at -3, G is at 2, so that is a length of 5. And we're asking, does that equal DK, which is at -1 and 6, giving us a length of 7. So are those two lengths equal? They're not, so this is false because 5 does not equal 7. When we look at number 2, we're looking at HK. So H is at 3, K is at 6, giving us a length of 3. And we want to know, is that equal to AD, which is at -4 and -1, having a length of 3? Since those two things are the same, then that is true because 3 is equal to 3. So those are congruent. We need to know what congruent means because when we look down here at midpoint, a midpoint is a point that divides a segment into two congruent segments, which you might remember from Math 1. So the midpoint's in the middle. So if B is the midpoint of AG, then we're looking at a segment that looks like this. We have a segment AG with D in the middle, meaning that AV is going to be congruent to VG. Those two things will be congruent. So if C is the midpoint of AB, looking at number 2 here, we want to draw that line out, that line segment out. So C is the midpoint of AB. So those pieces are congruent. If AC is 2x plus 1 and CB is 3x minus 4, then knowing that those two segments are congruent means that their lengths are equal, so we can set them equal to each other. So 2x plus 1 has to equal 3x minus 4. Take a second and solve that for x. So you see that I minus the 2x and then I added 4, so I got that x is equal to 5. The next piece of the question asks us to find AC and CB. And then I also added in this find AB as well. Oh, I think I covered it up on there. So you're going to take that 5 and plug it in for AC. So you're going to do 2 times 5 plus 1, which will give you 11. Then you're going to plug it into CB. So 3 times 5 minus 4 is also 11, which shouldn't be shocking because we knew those two things needed to be congruent, so we know that we've solved them correctly. And then to find AB, you would just simply add 11 and 11 to get 22. Sadly, I'm running out of time. We will go over this a lot more in class, but this one goes into the coordinates and finding the missing coordinate. You're going to use a piece of the midpoint formula that you've probably thought about from Math 1 and where you find the average of the two coordinates they give you. The one thing you want to make sure you always do is make sure you're doing big minus little so that you have your signs correct, and then also paying attention to what coordinates they're giving you. So in A, you're looking for the midpoint, while in B and C, you are given the midpoint. So your solve is slightly different for B and C because you need to actually go backwards instead of forwards. So we'll talk about this more in class if you have questions, and I will see you then. Thanks, guys.